Alright, so let us look at more derivatives. So number 16, f of x equals square root of x times tangent of x. So as you can see, in this case we have to use the product rule. So then f prime of x, taking the derivative of square root of x, consider square root of x as x to the 1/2 power. That means we get 1/2 and x to the negative 1/2, and then multiply that by tangent of x and plus square root of x times derivative of tangent, which is secant square x. So if you have to clean this one up a little bit, we get 1/2 square root of x times tangent of x plus square root of x times secant square of x. That becomes our answer. Number 17. Once again, we have to use the chain rule, but with the product rule here as well. So we get f prime is equal to, taking the derivative of x cubed, we get 3x squared times secant of e to the 3x minus 1 plus. So now I'm going to take the derivative of secant. So writing down x cubed, and then derivative of secant is what? Secant tangent. So we have secant of e to the 3x minus 1 times tangent of e to the 3x minus 1 times the derivative of inside by the chain rule. In this case becomes 3 times e to the 3x. Now if you have to clean this one up, we'll end up getting 3x squared secant e to the 3x minus 1 plus, so we have x cubed and then 3 e to the 3x, so we get 3 x cubed e to the 3x times secant of e to the 3x minus 1 times tangent of e to the 3x minus 1. Pretty long, but that's basically what it would have been. Now let's look at number 18. I'm going to do on the bottom. This one we have to use the chain rule. E to the something becomes e to the same thing, except that we have to take the derivative of inside. So f prime is e to the square root of 2x. That's how we're going to begin. But derivative of square root of 2x becomes, remember, square root of radical becomes 1/2 as an exponent, so we end up getting 1/2 and 2x to the negative 1/2 power. But by the chain rule, we have to multiply that by 2. Then of course these 2 cancels out. So when we clean this one up a little bit, we end up getting e to the square root of 2x over square root of 2x becomes our final answer. Alright, let's look at find the slope of the line tangent to this one when x equals 1. So they want you to find the slope. We don't have to find the tangent line. I guess we'll do that on the side anyway, but we just need to find the slope. That means we just have to take the derivative and set x equals 1. So then y prime here becomes 2x times ln of 3x by the product rule plus x squared times 1/3x, because derivative of ln becomes 1 over that expression. By the chain rule, we have to multiply that by 3. Then obviously these 3's cancel out, and x cancels out with x squared, becomes simply x alone. So y prime becomes 2x ln of 3x plus x. Now when x equals 1, Then we're going to get 2 times 1 and ln times 3, ln of 3 times 1. So which is equal to 2 plus 1 at the end because of x here. 2 ln of 3 plus 1 becomes our slope. Now, if you wanted to continue and then find the equation, then all you had to do was plug in the 1 in place of x. So I'm done with this problem, but if I were to continue to find the equation of the tangent line, it would have been, you have to find the y value, which is 1 square ln of 3 times 1, which becomes ln of 3, and you know the slope, and you know the x value, so it would have been y minus ln of 3 equals 2 ln of 3 plus 1 quantity times x minus 1 would have been the equation of the tangent line. Number 20. Okay, so in this case they want you to actually find the equation of the line tangent. So I'm going to do exactly the same thing. Y prime first, we get 6x minus 2. That's the y prime. And then you're going to plug in negative 1. So y prime of negative 1 is equal to 6 times negative 1 minus 2. So we get negative 6 minus 2 becomes negative 8. That's my slope. Then what is y value? Y value is simply plugging in negative 1 3 times negative 1 squared minus 2 times negative 1 plus 1. So we get negative 1 squared becomes positive 1, so we get 3 here, plus 2 plus 1, we get 6 as the y value. And as you can see, our equation would be y minus 6 from here. It has to be the opposite, as you know. Slope is equal to negative 8, and x plus 1, because opposite of that. That's basically what we end up getting. Alright, now let's look at number 21. Same deal. So y prime is equal to negative 2x. So then y prime when x equals 2 becomes negative 2 times 2, which becomes negative 4. That's my slope. What is y value? Y value is 5 minus 2 squared, which becomes 1. So our equation becomes y minus 1, which is equal to negative 4 slope times x minus 2 becomes the equation of the line tangent. Alrighty. Let's look at number 22. So the move that an object moves along the line. So position is given in this way, where t is greater than or equal to 0. What is the position's? What is the object's position at time t? T is equal to 3. We just have to plug in 3 in place of t because the function was position function. So then a is simply s of 3. Then we get 2 times 3 cubed minus 15 times 3 squared plus 24 times 3 minus 10. So then here this becomes 27 times 2 is 54. Now this becomes 9, so 9 times 15 I believe is 135. And 3 times 24 becomes 72 minus 10. So you can see that this one is equal to 126 when I add up 54 and then 72. So we get 126 minus 145, which is equal to negative 19. So negative 19 is the position. But how about B? They are looking for the velocity. So velocity, that means I have to take the derivative. So s prime of t is equal to 6 t squared minus 30 t plus 24. That's basically what we end up getting. Then s prime of 3, that's the velocity here. I'm going to plug in 3, then we end up getting 6 times 3 squared, and then minus 30 times 3 plus 24. Then this becomes 54 once again, minus 90 plus 24. Then this is the same thing as 78 when I add up 54 and 24, minus 90, we get negative 12. So velocity is negative 12. Then I want us to get the acceleration, then I have to take the derivative one more time. So I'm going to go for c over here. Then s double prime is the acceleration, so we get 12t minus 30. So second derivative of when t is equal to 3, that I'll be getting 12 times 3 minus 30. So we get 36 minus 30, which becomes 6 is our acceleration. Now how about d? Is the object speeding up or slowing down at t is equal to 3? So speeding up or slowing down depends upon the signs of the acceleration and then the velocity. When the signs are not the same, then it will slow down. When the signs are the same, then it will speed up. So as you can see over here, this is positive acceleration, and velocity is negative. Signs are not the same, so therefore it will slow down. And the reasoning is because acceleration and velocity have different signs. Now, when is the object at rest? At rest is velocity is equal to 0. So then I have to set the first derivative equal to 0. So here it goes e, and then s prime, which is equal to velocity. We have to set that equal to 0, which was 6t squared, and then minus 30t plus 24. So I'm going to factor 6 out. Then I get t squared minus 5t, and then plus 4. Then this is factorable, so 6 times t minus 4 and t minus 1, that means t velocity will be equal to 0 and t is equal to 4 or 1. So we have two values. So that's what we did. And then when is the object moving to the right? Moving to the right means velocity has to be positive f. That means I'm going to set up the number line here. 1, 4, and then of course starting point is 0 and up. So I'm going to check up on different values, plug that into velocity. But I can just put them over here, it's because all I'm looking for is positive versus negative. So what if t were to be equal to 0.5? 0.5, that means 6 is simply 6. So 6 times 0.5 minus 4, and then 0.5 minus 1. I realize that this is negative, that's negative. So two negatives makes this one into positive. What if I have numbers between those two? Let's say t is equal to 2. Then I get 6 times 2 minus 4, and then 2 minus 1. So this one is negative while this one is positive, so combined becomes negative. Here I can say t equals maybe 5, how about that? Then 6 times 5 minus 4 and 5 minus 1, and both of them are positive, so I know that this is positive. We're looking for when the object is moving to the right, so that means we have two intervals here, 0 through 1 or 4 to infinity. That becomes our final answer for number F. Alright, number G. How far does the object travel in first 3 seconds? So in this case, this might be a bit confusing. Are we talking about the position, or are we talking about the total distance? Usually, when we talk about how far the object is traveling, in math class, we are usually referring that to total distance it traveled. So that means total distance which we have to check upon is not only the beginning but also ending, but also where the velocity is changing from positive to negative or negative to positive. So technically what we have to do is we have to check upon velocity, and the time, and then position at 0 because it was starting point, 1 because that was a turning point, and 3 because that was the ending point. So when t was equal to 0, you just have to plug in 0. I know that it was at negative 10. And when t was equal to 3, I know the location we found it to be negative 19. Now, 1, I'm just going to plug in 1 here. When you plug in 1, this becomes 2. That becomes minus 15. And this becomes positive 24 and minus 10. Then total, it becomes 26 minus 25, which becomes 1. Then let's try to calculate the total distances traveled. From negative 10 to 1, it traveled 11 units. 1 minus negative 10, right? How about 1 through negative 19? It traveled 20 units. So total combined together, total distances traveled was 31 units, would be our answer. Alrighty, so let's move on to the next question, number 23. So we know that h of x is given in this way, and then s of x is given in this way. So they want us to find h prime of 1. Then in order for us to do this one, we have to use the chain rule here. Then h prime of x is f prime, because it's the outer layer, and keeping the inside alone. But by the chain rule, we have to multiply by g prime of x. So based upon this idea, h prime of 1 now becomes f prime of g of 1 times g prime of 1. So let's try to figure the first portion out. G is this line here. Let me highlight this one so that we can see better. The green one is G, and then not highlighted one is F. When x equals 1, I realize that y is equal to 1 as well for G. So we get this one is equal to f prime of 1 times g prime of 1. The f prime of 1 is a slope at that particular point. So at this point, you see that as it moves to the right, it goes up by 2. As it moves to the right, it goes up by 2. So we know the slope here is equal to 2. How about g prime of 1? It's going down. As I move to the right by 1, going down by 1. That has been the pattern. As I move to the right by 1, going down by 1. That is the slope. So it becomes negative 1. So when we multiply them together, we end up getting negative 2. So negative 2 would have been the answer for h prime of 1. Let's go for s prime. In case of s, it's a product rule. So s prime of x is equal to f prime of x times g of x plus f of x times g prime of x. Then we just have to plug it in. S prime of 1 now is equal to f prime of 1 times g of 1 plus f of 1 times g prime of 1. So earlier we calculated that f prime of 1 was equal to 2, and g of 1 we calculated to be 1 plus f of 1. F of 1 is, I'm right over here, which would have been 2. So it was kind of interesting. Not only the value was 2, but slope was 2 as well at this particular point. And g prime of 1 was -1. We calculated that earlier. Then we get 2 minus 2, which becomes 0. That's the answer. Alright, let's look at number 24. So similar idea is happening here. N prime of 2. So then here we have to realize that n prime of x, we have to use the quotient rule. So here g of x has to be squared on the bottom. So first f prime of x times g of x minus f of x times g prime of x. Then here we get, I'm looking at n prime of 2, so then that means f prime of 2 times g of 2, just plugging in the numbers, f of 2 times g prime of 2 all over g of 2 squared. What is that equal to? F prime of 2. F prime when x equals 2 is equal to 4. G of 2. G is here, of 2 becomes 3. Minus f of 2. F of 2 here equals 5. And then g prime of 2 is equal to 4. Multiply that by 4 over g of 2, which was 3, so we get 3 squared. Then we get 12 minus 20 over 9, so we get -8 over 9. Becomes our answer. Alright, how about h of 1? H of 1 was, once again, it was the chain rule. So h prime of x, as we talked about it earlier, outside, which is f prime of g of x, multiply that by g prime of x. So h prime of 1 is f prime of g of 1 times g prime of 1. I'm just plugging in 1 in place of x's. Now let's try to figure out each value. G of 1. G of 1, x equals 1 is equal to 2 here. So we get f prime of 2. That's what we end up getting. Times what is g prime of 1? That was equal to 3. Multiply that by 3. But what is f prime of 2? F prime when x equals 2 is equal to 4 here. So we get 4 times 3, which is equal to 12. Becomes our final answer for h prime of 1. Alright, let's try to look at this one. If f of x is this expression, then what is f prime of 0? When you look at this one, it looks a little bit complicated. So let's try to rewrite this one. This is equal to x squared minus 2x minus 1. And then cube root is 1/3 as an exponent with the square, so we get 2/3 as our exponent. So f prime then becomes 2/3 comes to the front. We get x squared minus 2x minus 1 to the negative 1/3. Multiply that by 2x minus 2 by the chain rule. So if you have to clean this one up a little bit, we'll end up getting 2 times 2x minus 2, because negative x, want to bring this one down, so we get 3 times cube root of x squared minus 2x minus 1. So the fact that we are plugging in 0, then all the terms with x become 0, so we get, on the top we get 2 times negative 2, that's the only thing that left, 3 times on the denominator, 0, 0, cube root of negative 1, but we know that cube root of negative 1 is negative 1. So here on the top we get negative 4 over negative 3, which is 4 over 3 becomes our answer. Number 28. This is the implicit differentiation. Find dy over dx. So that means first one is 3x squared. Second one, we have to use the chain rule because y is the function of x. So we get 3y squared times dy over dx equals 18y. That means simply 18 is the derivative, but by the chain rule we have dy over dx. Then what we can do is we can bring all the terms with dy over dx in one side. So we end up getting 3x squared is equal to 18 dy over dx minus 3y squared dy over dx. So when you factor out dy over dx, we get 18 minus 3y squared. So of course, to have that alone, we get dy over dx is equal to 3x squared all over 18 minus 3y squared. But notice 3 is common in all the terms, so we cancel out 3's. Then we end up getting x squared over 6 minus y squared becomes our final answer. Alright, let's move on to number 29. Same deal here. So by the product rule we get 2x times y plus x squared dy over dx. So I just found the derivative of this one by the product rule here. Same thing here, we end up getting derivative of x becomes simply 1, so we get the y squared. But minus, the reason why I put down the minus sign was I supposed to have plus, but negative sign carried over. So x times 2y, derivative of y squared, times dy over dx equals 4. So all the terms with dy and dx stays, the other two terms goes over the other side. So we get dy over dx. When I factor that out, then I'm left with x squared minus 2xy equals 4 minus 2xy plus y squared. So having dy dx alone is 4 minus 2xy plus y squared all over x squared minus 2xy becomes our answer. Alright, so we're going to stop here for now, and I'll see you later. Bye-bye.